Hello everyone and welcome back to Techmine Guru. I am your coach Supratim and today we are tackling something incredibly important. We are diving into DSL lecture 30 and focusing on interview problems on linked list. Linked lists are the ultimate interview gatekeepers. Why? Because pointers get messy, null references crash your code, and tracking state is an absolute nightmare. But today we will conquer them. We are going from basic searching to complex deep copies, mastering the blueprints. So here is our agenda for today. So in level 1 we will learn about searching in the linked list and how to insert an element in the linked list. So it will be like a warm up for you. In the second level, we will learn about deleting the first occurrence, where we will learn about the pointer manipulation. Next, we will learn about delete all occurrence of a particular character. In the next level, we will learn how to reverse a linked list. And finally, we will deal with a boss level problem, where we will learn how to do a deep copy with respect to random pointers. So let's start with question 1, which is searching in a linked list. So the goal here is simple: check if value X is present in the linked list or not. While arrays are organized, allow for things like binary search, linked lists are completely unorganized. Because of this, linear search is strictly required. We have to traverse while our temp node is not null, checking if the data matches our target or not. So linked lists are always linear, which means our time complexity will be O of n and space complexity will be O of 1. So let's see how we are able to search a target element in a linked list. Suppose you have been given a linked list having 10, 20, 30, 40 and 50, and you have to search X, which is 40. So if it was an array, it would have been very easy, right? Because we would have been applied binary search here. But in linked list, we have to traverse over all the elements till we reach there. So let's see the code for the same. The code is very simple. We have to take a temp node, which we will assign as the head pointer, right? Now we will run a loop, and inside the while loop, we will check if temp is null or not, so that we can know that we have come to the last node of the linked list or not. Now inside the while loop, we will check a condition that if temp.data is equal to X, we will return true, or else we will keep iterating to the next element. So suppose the linked list is given as 10, 20, 30, 40 and 50, and you have to search this 40. So initially our temp node and head node will be same. So our head will be given as 10, and we are initialized node temp is equal to head. So this is also 10 right now. Now we will check whether this node is null or not. So this node is not null. We will check whether this node's data, which is 10, is equal to our X or not, which is 40. So this condition will not work. So we will do temp is equal to temp.next. So what is there in the temp.next? So temp.next will be here now. And now whatever element is present here, we will call it as a temp. Since initially temp was assigned as head, so what is the next element? We will do temp is equal to temp.next, so that we can iterate to the next element. Again, we will check whether our new temp is equal to null or not. We will say that 20 is not equal to null. Also inside the if, we will check if 20 is equal to 40 or not. So this condition will again not work. We will again iterate to the next element. So this is like I++, which we are using in the case of array. Again, it will check whether the node in which 30 data is null or not. It is not null. So now it will again check whether 30 is equal to 40 or not. This condition will again not work. It will again do I++, which is temp is equal to temp.next. Now again it will check whether this node is null or not. It will say no. So it will come inside the loop. It will check temp.data is equal to X or not. This time our temp data is equal to X. It will return true from here. So we will say that we have got the element. So what if the X was 60? So in that case, again this temp equal to temp.next would make the temp to point to this variable. Again we will check whether 50 is null or not. We will say that 50 is not equal to 60. Again this condition will not work, and we will point to the next. Now temp.next will point to null, right? And since temp.next will point to null, we will break out from this loop and we will return false. So this is how we will check a element present in the linked list or not. Now let's move on to the next question, that how insert an element at an index k. So here we have to follow one golden rule, that for inserting an element in index k, we have to traverse till k minus 1 times. So suppose you have to insert element 4 at position 3. In that case, you have to stop your pointer till the second position, so that you can insert 4 in the middle of this. So when you insert a new node at that time, what will you have to do? You have to do some pointer manipulation. So let's see the code and let's understand how we can do the same. So in the first line, we have created a new node, because when you have to insert a node, you have to create a fresh node, right? So you will do new node and you will pass the value and the next node as nil. Now again assign head to temp variable. For that you will do node temp is equal to head. Since you have to traverse till k minus 1 times, so our for loop will run from I is equal to 0 to k minus 2, and just you have to iterate till there. So you will do temp is equal to temp.next. So this will stop at this position, right? After stopping at this position, whichever new node which has been created, we have to assign these pointers with respect to each other, so that they become connected. So now we will do new node dot next is equal to temp.next. So what is present in the next right now? Nil, right? And what is present in the temp.next? In temp.next we have 9. So this temp.next means this node will go to the new node dot next. Previously our new node next was nil. Now it will point to this temp.next, which was 9. So this complete new node will go into this temp.next. Earlier this connection was there, so this connection will break, and this will now hold the new node, and the new node will now hold the pointer to the 9. So let's see a dry run of this code. So suppose we have initialized node new node equal to node 4 nil, which will create a new node. Now we will assign our head to the temp. So this was head. Now this will become temp, right? Now the loop will run from I is equal to 0 to k minus 2. So what is k? 3. So the loop will run till 1, right? So when I is equal to 0, it will just do traverse. So now our new temp will become this one, by temp is equal to temp.next. So it is like I++. We will move over the linked list using this line. Now, when I is equal to 1, again our temp will be now pointed to this one. So our new temp will be this one now. Now we have to stop there, right? Now this will be our temp. Now the node which we have created earlier, we will keep the temp.next. So what is the current temp now? This 8, right? This 8 is our current temp. And what is there in the temp.next? It is 9. So it will come to the new node. New node's next. And what was present in the new node next? Earlier it was nil. Now this value will go here. So this pointer will point to 9. And in the temp.next, which is this pointer will hold the new node now. So instead of pointing here, it will break the link from here and it will start pointing to the 4 node. And also you have to handle one edge case here. What if your head is null? In that case, your k will be 0. That is, you will insert at the head of the element. So for that, if k is equal to 0, in that case, you will again create the new node, right? So this new node will be created. And now in the new nodes next, you will put your head pointer so that whatever present in the current linked list directly comes to the first node's next pointer. And now head will get changed because earlier this was head and we are inserting before the head. So we have to assign the new node as the head. So now in the next line, we will do head is equal to new node. So this new node will become our new head. So what is the time complexity? Since we are running a loop from I is equal to 0 to k minus 1, so our time complexity will be O of k. And since we are not using any extra space, so our space complexity will be O of 1. So let's see the next problem, which is to delete the first occurrence of an element. So suppose you have been given a linked list 1, 8, 4, 2, and 12, and your x is 4. That whichever is the first occurrence of 4, you have to remove it from the linked list. So after removing, your linked list will become 1, 8, 2, and 12. So the logic is to find x and bypass it. But if there is no x, there is no change. So you have to achieve this by routing temp.next directly to temp.next.next. So in this, you have to check every time whether you got the data or not using temp.next. So you have to stop one element before the element to be deleted so that you don't lose the reference of that deleted node. So instead of doing temp.next, if we have done temp.data, then again we have to keep track of our previous pointer, which we can't because this is a single linked list. So we will stop at one position before. So let's see the code for same with a dry run. So our example is 1, 8, 4, 2, and 12. And our target is 2. So we have to remove the 2 nodes. So here we will again start with the edge condition where we will check whether our head is null or not. If our head is only null, so there is nothing in the linked list and we cannot delete our any occurrence, either it is a first or a last. So we have checked if head is equal to null, we will return from the function. Suppose if we want to delete the head only, which is the first element. In that case, all other elements will be as it is, right? You cannot lose the reference of the head pointer. So for that, you will do temp is equal to head, and then your new head will become head.next. Suppose if you have to delete 1, in that case, this head and temp both will point to here. And now we are doing head is equal to head.next. Now our new head will be this one. And after that, we will free temp and we will return. So here I would like to tell you one thing. So in Java, this is automatically done by the garbage collector. But in other languages like C, C++, you have to explicitly use this free so that when your garbage collector works, it will pick up that pointer which is not having any reference. Next, we will move to the same code which we have learned till now. So we will assign temp is equal to head. Now we will check if temp.next is not equal to null or not. So while deleting, you have to remember one thing, that you have to check one element before whether we have got null or not, right? So we will check temp.next is null or not. So suppose our temp is here and our head is here, right? So now it will check temp.next, which is 8. So it will check 8 is null or not. It will say it is not null. Now it will check if temp.next means this element's data, which is 8, is equal to our target 2 or not. It will say no, and we will simply iterate the linked list. And for iterating the linked list, what we do temp is equal to temp.next. Now our new temp will be here. Our temp.next will be here. So when our code will start working for this block, it will check whether its next node, which is 4, is null or not. It will say no. Then it will check whether the next node's data, which is 4, is equal to 2 or not. It will say no. Again, it will do temp equal to temp.next. Now again, our new temp will become this one. Now it will again check whether temp.next is null or not. Again, it will find this 2. So this is not null, but this time it will see that temp.next, which is this 2 node, the data of that is equal to x, right? Why? Because temp is this node and temp.next.data means this 2 is equal to 2 or not. So it will say yes. Now it will keep this value temp.next in a variable called p, which will also be a node type, and it will do temp.next is equal to temp.next.next. So what is temp.next.next? So temp is here, right? So temp.next is this one, and what is temp.next.next is this one. It will break this link and it will say that this 12th node will link now to this temp.next. So this link will break and this link will directly hold the temp.next.next element. And after that, we will do free of p if we are writing the code in C or C++, or else in Java, we can skip this. And finally, we will break, saying that we have deleted the element. Now, we will again do temp is equal to temp.next. Since we have deleted this element, our new temp.next will be here. So this will be our new temp now. Now it will check whether temp.next is null or not. Here, we don't have any other element. That means it is nil. So we will come out of this while loop and our code will return head. So here you have to remember just 2 points, that every time while iterating, you have to check whether that temp.next is null or not. If it is not null, then you have to check the temp.next data is equal to the item which we want to delete. Then we will assign that value to a temporary variable, say p. Now we will insert the value present in temp.next.next to our temp.next. So our this link is broken. And finally, we will break out of the loop and we will iterate using this temp equal to temp.next. So if you see, this is running only one file loop. So our time complexity will be O of n. And since we are not taking any extra space, our space complexity will be O of 1. So let's see the next problem, which is to delete all occurrences. So a practical use case will be, suppose the 1+ decides that they want to remove all their defective models from their control process. Suppose their control process chain, these data are device IDs. So the linked list is 2, 2, 2, 1, 5, 2, 2, and 9. And it finds out that the device ID with ID as 2 is a defective piece. And you have to remove all such defective pieces. So how will you do the same? So here we will handle the case where you need to delete the defective pieces first from the head also, and then over the body also. When this process will be done, after that you will be left with 1, 5, 9, and null as the linked list. So let's see this dry done with this code. So initially our head will be this one, right? We will check if head is null or not. If head is not null, which is not, we will check whether that head.data is equal to x or not. Since head.data is equal to x, we will assign this head to our temporary variable, and then we will move our head to the next pointer. Now our head will become this one, and our temp will be having this. Our head will become this. Since temp is now storing the defective piece, we will free temp. So this will be removed from the linked list. Now again we will check whether this head, which is on this 2 right now, is null or not. It will say no. Then we will check whether head.data is equal to x or not. Since this is also 2 only, so this is also our defective piece. Again we will assign this head as the temp, and then we will move the head pointer next element. So head.next will be having this one. Now this will become our new head. Again, this temporary variable we need to remove since it is a defective piece. Again it will go from the array. Again it will check whether head is null or not. It will say no, and it will say the next condition, which is head.data is equal to 2 or not, which will say yes. Now again it will make it a temp, and it will move its pointer to this next element, and it will free the temp variable again. Now again it will check head is equal to null or not. It will say no. Again it will check head.data is equal to x or not. Now this time our value is 1, so this is not a defective piece. So this will come out of the while loop. But the observation here is, while coming out of the while loop, it has cleared all the head of the linked list which is having the defective pieces. Now our control will come to here. Here we will do temp is equal to head again. Now for moving into the body, for that we initialize node temp is equal to head, right? So we will again do the same thing. We will do node temp is equal to head. Now we will check whether this temp is null or not. And also we will check whether the next element is also null or not. Since we have to delete those occurrences, as we have already known from the last question, that when you have to delete an element from linked list, you have to check for both the things, temp and temp.next. So here we will check whether 1 is null or not. It will say no. Once next is null or not. So once next is 5. It is also not defective, so it is also not null. Now we will see if temp.next.data is equal to x or not. So what is temp.next.data? It is 5. Since 5 is not equal to 2, we will simply come to the else block, where our new temp will be this one. Now a question can arise that why we are checking temp.next.data instead of temp.data, because came out of the head while loop after checking this one, right? So we don't need to check that element anymore. So we will check the next element from that head. Since head is only assigned as temp, so we will change the temp.next data. So since 5 is not equal to 2, we will do temp equal to temp.next. Now our new temp will point to here. Now again it will check whether the 5 node is null or not. It will say no. Again it will check the 5's next, which is 2, is null or not. It will say no. Now this time it will check temp.next.data, which is 2, is equal to the defective piece. So here we will do temp.next.next as temp.next. What is temp.next.next? Temp is 5, temp.next is 2, and temp.next.next is this 2. Now this 2 will be directly pointing to this temp.next. So this 5's next will hold 5's next element. And since we are giving the temp.next.next value to our temp.next, that's why every time we have to check that whether temp.next is also not null or not. Otherwise it will give null pointer exception. Because if we don't see this condition, if our temp.next only becomes null, then in null.next it will crash the code. So to avoid that, we will check temp.next is not equal to null or not. So after this line, this 2 will be removed, right? Now our temp node is still pointing to 5. Now we will see again temp.next data, which is now pointing to this 2 is equal to x or not. It will say again it is 2. So it will now point temp.next.next, which is 9, to with this 5. So this 5 will link to this 9 now. Again it will check whether 9 is equal to x or not. It will say no. This time now our temp will move here. Now it will check whether 9 is null or not. It will say no, but this time temp.next is null, right? Because temp.next is holding null right now. So this will say yes, and it will come out of this while loop. So remember, in this, whenever you get a defective piece, your temp will not change. Instead of that, your temp's next to next element will become its next element. So your temp will start pointing to its next to next element. So whenever you delete in linked list, your temp will start pointing to its next node. So now we reach the core with question 5. So where you have been given a linked list and you have to reverse the linked list. Since we have already seen that how to reverse an array, in the similar fashion, we will see how to reverse the linked list. So this is also a lead code problem. The link I mentioned in the description as well. So here you have to use 3 pointers because you cannot reverse a linked list until you save the next node, or you will lose the rest of the linked list. So here you have to keep track of previous, current, and next pointer. So that's why it's called 3-pointer dance. So let's see the code and understand the same. So initially in this, you don't have to take temporary variable. Instead of that, you will use current variable. So current variable will be assigned as head. And since you can already feel that there is no element present before the head, so our previous variable will be null. Now our head is here. So this will be our current pointer, right? And what is there in the previous? In previous, nothing is there. That's why previous is null. Now we will save the next pointer. So what is there in the next pointer? It will be current.next. So in the first iteration, this is C, this is current, right? So this will become next. And now you will assign the previous value, which is initially null, to our current next. So this connection will break and this connection will start pointing to null, as you can see here. So initially previous is this one. Now since the connection has been made, now we have to iterate it and reassign the pointers. Now our current will become P using P is equal to current. So our new P will be this one, and our next pointer will become current pointer. So this will become current, and our next iteration will start. In again next iteration, we will make our next as current.next. So our new next will become this one. And till now we have broken this connection. Now we will break this one as well. So let's see how. So our previous will become current.next. So what is our current.next? This pointer, right? So this pointer will become our previous. So what is there in the previous? 5. So previously 6 was pointing here. Now 6 will start pointing this side. Again we will do previous equal to current. Now this will become previous and this will become current, right? Because in the next line we will do current equal to next. Now again next will be equal to current.next. Now next will store nil, right? Our current.next, what is there in the current.next? So our current is this one, right? So our this connection will now break and it will start pointing to anything present in the previous, right? So our previous was 6 now. So it will start pointing this direction. Now our current will become previous, means this will become previous now, and current will be next. And what is present in the next? It is nil. So our current will be nil now. Since we are checking the condition that once current becomes null, we will come out of a loop, and now whatever present in the previous will become our new head. So this P will become head now. So initially we started from this head, and after reversing all the links, we will assign back the previous to our head, so that when we do iteration now, it will start moving in this direction, right? So finally we arrive at our boss level question, which is deep copy, where you have been given a linked list and you have to create a clone of that linked list, which you need to do by using deep copy. And also in your linked list, there will be random pointers available. So suppose your linked list is 1, 2, 3, and 4. So this is like next pointer for each node, and this is like random pointer. So 1's random is 2, 2's random is 4. Similarly, 3's random is 1, and 4's random is 2. So how we can approach this? So idea 1 can be, we can use Hashmap here. That is, we can map original node with the copy of the node. Since we have original node and copy of the node in a Hashmap, then while creating random pointers for our cloned linked list, we will do temp2.rend is equal to hashmap.get of temp.rend. So let's understand that with the code. So you have initialized Hashmap with both key and value as node only. Since you have to create a separate copy of the linked list, so first you have to create the head node. So for that, we will do node head2 is equal to new node of head.data, because from the original linked list, you will copy the heads data, which is 1 inside the head2, and you will create a new node, right? Now, in the similar fashion, how we traversed over the linked list, we will do the same thing for both the nodes, because we don't want to destroy the original node and we want to create the new node as well. So now new node, suppose 1 dash has been created. So head is assigned to temp and head2 is assigned to temp2. Now before you iterate over your original linked list, you have to store this head into the Hashmap. So you will insert the key as the original node and value as the copy node. So 1 will be stored as a key and 1 dash will be stored as a value, so that when we create the random pointers, we can take help of this Hashmap. So you will run a loop from temp.next, where you will check temp.next is equal to null or not. So while iterating over the original linked list, you will keep creating the new linked list. So here you will do temp2.next. What is temp2? This is head2 only. This is similar to head2 only. We'll be creating a new node, and inside that it will keep the data as temp.next.data. So what is there in temp.next.data? 2. So it will create a new node with 2. And now you will iterate over the original linked list by making temp is equal to temp.next. So your new temp will now come here. And similarly, your temp2.next will become temp2. So now temp2 will start pointing here. And every time you save each node, you have to insert into the Hashmap. So while you iterate over this original linked list, your clone linked list will also get created. 1 dash, 2 dash, 3 dash, 4 dash with their respective links. Since your temp and temp2 will be pointing to the last node, now you again assign them back to the head node, so that you can start again from the starting, so that you can connect your random pointers as well. So for connecting the random pointers, you will just iterate over your original linked list, where we will check temp is not equal to null, and for assigning the random pointer, whatever we have stored while creating the linked list, we will do the same. So temp2.rand will be getting value from the map on the basis of the temp pointers rand variable. So suppose temp.rand was holding 2, right? So what is present in the 2? So that will be assigned to temp2.rand. So where is temp2? Temp2 is here, and temp.rand was holding 2. So this link will happen. Again, we will iterate in both the original and the cloned linked list. So our temp will become here, and our temp2 will come here. We will again check what was present in the temp2's rand. It was 4. Again, it take that value 4, and it will keep into the temp2.rand. Similarly, when we will move to 3, it will check it's in the original linked list. It was connected to 1. It will fetch that value. It will connect the same to clone pointer. So this is how you can do using the hash map. But if you use the hash map, your space complexity will become O of n. So let's see that without using the hash map, we are able to do the same or not. So here our idea will be, instead of keeping anything, we will start creating clone linked list elements side by side. So the idea is, initially 1 was connected to 2. Now we will insert 1 dash in the middle of 1 and 2. Similarly, 2 was connected to 3. Now we will insert 2 dash in the middle of 2 and 3. And similarly, 3 was connected to null, and we will insert 3 dash in the middle of that. So the first step is this one. After that, in the step 2, you have to have a good analysis that your temp's rand's next pointer will be stored in temp.next.rand. So we will understand this thing in a better way. And finally, in the step 3, you will apply your detach logic, where you will separate the list back, and you will remove the original elements from the linked list, and you will keep the copied value. So let's see the first step in the code. We will assign t is equal to head. We will check whether temp is null or not. We will create a new node with the temp's data, and whatever present in temp's next, we will assign that to new nodes. So earlier we have learned to insert one element. Here we will keep on inserting 50 copied elements to the linked list. So in t.next, 2 was present. It will go to new nodes.next, which is 1 dash, and now new node will go to t.next. Now this t will start pointing to this one. Similarly, we will insert 2 dash. Similarly, we will insert 3 dash. And after this step, we will have to do t is equal to new node.next. So basically, you have to create a new node. You have to assign the temporary node's next variable to the new node's next, and then you have to keep your new node into the temporary's next, so that it gets linked back. And finally, whatever present in the new node's next will now become the new temp, so that you don't iterate on this one again. So first your temp will run here. It will insert a node, and directly it will come here. So it will bypass this t. Similarly, it will create this link, it will create this link, and finally t will move to this 3. So this is how you will create this and apply the interleaving trick. Now this is linking of the node. Now how will you assign back the random pointers? So for that, you will again initialize temp is equal to head. Now we will again run a loop on the temp variable, which will be equal to null. You will check if t.rand is null or not. So if your random pointer is not null, that means you have to do t.rand.next is equal to t.next.rand. So let's see how. So suppose initially our 1 was connected to 3, 3 was connected to 2, and 2 was connected to 1 using the random pointer, right? So let's see how we can do that. So again, we will start from the head. We will see t.rand. What is there in the rand? It is 3. And what is next? It is 3 dash, right? This we will keep to t.next.rand. So what is present in t.next? 1 dash, right? And what is present in this rand? We are assigning back the t.rand.next. So t is here, t.rand is 3, and rand.next is 3 dash. So this will assign back to t.next.rand. So this will assign back to this one. So 1 was connected to 3. Similarly, 1 dash will connect back to 3 dash. Again, we will do t is equal to t.next.next, so that we don't come to this node. Again, we'll come to this 2. Now, initially 2 was connected to 3. So 2's rand was 3, and 3's next is 3 dash, right? T is at 2. So t's next is 2 dash. So this 3 dash will get connected to 2 dash. So how 3 was connected to 2, in a similar fashion, 3 dash will now connected to 2 dash. And similarly, for the last element also, it will do the same. And once this initial pointers, next pointers, and random pointers are assigned, we will apply the detach logic. So how we will do that? We will take a new head as head2, where we will assign head.next. Now we will need 2 pointers. So t will be holding the original head, and t2 will hold the clone head. Now our loop will run over the temp variable. So every time, instead of doing temp.next, we will do temp.next equal to temp.next.next. So our temp.next.next, which is this one, will be assigned to temp. And this is for iterating over the original array. And meanwhile, we will check our t2, which was pointing here, is also null or not. Our t2 will also start holding the next to next pointer, because for t1, the cloned node is in the middle, and for the cloned linked list, the original linked list will come in the middle. So every time when they will iterate, they will do t.next.next and t2.next.next, so that they can skip their middle elements. And after doing that, we will do t is equal to t.next and t2 is equal to t.next, so that they move to the next element. So this is how we will detach from the original logic. So before we wrap up, let's quickly review the linked list cheat sheet today. For searching we use linear traversal where we created temp is equal to head and the time complexity was O of n and the space complexity was O of 1. For inserting at index k, our time complexity was O of k and our space complexity was O of 1, where we were traversing till k minus 1 element, but in this case, we have to handle the edge case of the head is equal to null. Then we learned about deleting the first occurrence, whose time complexity was O of n and space complexity was O of 1, where we applied the readout logic, where we did temp.next, and also you have to remember that in which language you are coding so that your garbage collector can pick up node which is not referencing anything. Now, after that, we saw delete all occurrence, whose time complexity was O of n and space complexity was O of 1, where we again ran a loop initially for our head pointer if our head is only defective, and then over the body. And then we learned about reversing a linked list whose time complexity was O of n and space complexity was O of 1 using 3-pointer techniques with pre, current, and next pointers. And finally, we learned how to do a deep copy of a linked list which is having random pointers also, whose again we saw two approaches. One using Hashmap, whose time complexity was O of n and space complexity was also O of n, and then we optimized it using the interleave, the key inside, and the detached logic. The key inside was t.next.rand will be equal to t.rand.next, and which gave our space complexity as O of 1. So lecture 30 is now complete. You now possess the foundational schematics for dynamic memory. In our next lecture, we will cover the introduction and problems on stack. If you found this video helpful, hit that like button and subscribe to Techmine Guru. Till we meet again, keep learning, keep coding, and keep optimizing.